Okay, to start this problem, we it's a good idea to detail our givens. And whenever there's two objects in a problem, I like to um, put my givens, um, make a little space for one object. So I'm going to start with the truck. Now the truck, maybe I'll use a different color with the truck. The truck has a velocity of 150 kilometers per hour. And that's a steady velocity. We'll say that's forward. So that means that it is not accelerating. The only other, we don't really know anything else about the truck. So because this is a kinematics problem and these are the other variables, we're going to put them in here and we'll analyze them later and see if we're going to need them. Now the police car has a little bit more information. The initial velocity of the police car is 0. The acceleration is 2 meters per second squared forward. And again, let's just write down delta D and delta T. Now, there's a reason why I haven't made these unique. So this delta T is actually the same as this delta T, and this delta D is the same as this delta D. And that's important because that's the only way we can actually solve this problem. So let's just make a graph. This will be a D versus T graph. And we'll just highlight what the truck is doing. The truck passes the police car, say at the origin, so that'll be time 0. And it's going at a steady rate. So therefore, it looks like that. So that's the truck. Now, a police car is accelerating, so therefore its dt graph is a curve. So it starts here, and then it curves. Oops. Let's get rid of that. So I'm going to draw a curve. So it curves like that. So it's a parabola. It's a half of a parabola. And so there's two intersections. There's this one, and then there's this one. We're interested in this intersection right there. So part of the problem is what is the time of the intersection? So that's going to be down here. And the other part is what is the distance? And that's going to be right there. So let's start with the expressing everything we know about the car. So we're going to use a kinematics problem that has all of these characteristics. And the kinematics relationship that I'm looking at is delta D is equal to V I times delta T plus a half A delta T squared. And for the truck, it's delta D is equal to V times delta T. And the reason why there's no term here is because the acceleration is 0 and this term disappears. So because delta D is for the truck is the same as delta D for the car, as we can see up in the graph, we can merge these two equations together. So I will do that. So I'll just put these together and I'll just write it with V delta T on one side, and then I will write it as V1 delta T plus a half A delta T squared. Now this is 0 because V1 is 0. And I'm trying to solve for t, and I'll notice that these t's are the same, so I can actually cross this out, cross that one out. And this also told me a little bit of information about the interception as well. 0 is a solution to this equation. And we can see that on our graph. The truck and the car intersect at 0 when time is equal to 0. So that is not the answer that we want. We want the second answer. So we're going to solve this equation now for delta t. So I'll just switch to black now because we're now merging both. Actually, I'll do it in all colors. So I'll solve for t. So that means I get a 2 from over here. And I get a v. And then I divide by a. And I'm left with delta t on the left side. So it's 2 times the velocity of the truck. Now, one thing I forgot to do is I forgot to change this to meters per second. So the velocity of the truck in meters per second is 150 divided by 3.6, and this ends up being 41 2/3 meters per second forward. So I'll plug that in here. And I'll divide by 2, and they cancel out nicely, so my delta t is actually equal to this. So that's the first part of the problem. The second part of the problem is I have to figure out what the distance is. Well, that's easy enough. I can just use one of these relationships, and I might as well use the easiest one. So delta d ends up being v times delta t, and that's equal to 41 2/3 times 41 2/3, because they're both the same number. So I square that, and that gives me 1,736 meters forward. So my final answer, which I'll put in red, is therefore they meet at 41 2/3 seconds and at, I guess I'm running in a cloud here, and at 1,736 meters forward. There you go.